Hello grade 10 students. Welcome to another virtual class. I am Miss Madhu Badke. We are studying chapter 8 Trigonometry and we are learning how to apply trigonometric ratios of some specific angles in solving questions of exercise 8.2. In today's video lesson, we will continue with the same and solve some more questions of this exercise. We have solved first question of this exercise in previous two videos. So let's continue with question number 2. Choose the correct option and justify your choice. In order to find the right option for this expression, we need to evaluate this expression. 2 tan 30 degrees divided by 1 plus tan square 30 degrees. So let's draw a right angle triangle with one angle as 30 degrees. Let's mark the opposite side and adjacent side with respect to 30 degree angle. We have also learned the Pythagorean triplets that can be the side of this triangle. Opposite to 30, we have 1 unit. Longest side is hypotenuse, that will be 2 units. And the adjacent side to 30 degree angle will be root 3. So tan 30 from this triangle is opposite upon adjacent, and that is equal to 1 upon root 3. So 2 tan 30 degrees divided by 1 plus tan square 30 degrees is equal to, substituting value of tan 30 degrees, we get 2 into 1 upon root 3 divided by 1 plus 1 upon root 3 square. Now recall, we have learnt that tan square theta is same as tan theta whole square. The square over here means it is the square of the ratio that is represented by tan theta. So I have squared the ratio given by tan 30 degrees. Simplifying, we get 2 upon root 3 divided by 1 plus 1 upon 3. That is 2 upon root 3 divided by 3 plus 1 upon 3. On simplifying further, we get 2 upon root 3 divided by 4 upon 3. So this is 2 upon root 3 into 3 upon 4. Now remember, whenever we divide two fractions, to simplify further, we multiply the reciprocal of denominator to the numerator. And that is what we have done over here. Now this 3 can be split into factors root 3 into root 3 divided by root 3 into 2. So we get root 3 upon 2. Now we have to look in the figure and find the angle corresponding to this ratio. So root 3 is the adjacent side and 2 is the hypotenuse. But these sides, adjacent and hypotenuse, are marked with respect to 30 degree angle. So this ratio root 3 upon 2 will be cos 30 degrees. However, cos 30 degrees is not one of the options. So we will have to look at the other angle, that is 60 degrees. So root 3 is opposite to 60 degrees and 2 is hypotenuse. So opposite upon hypotenuse will give us sine of 60 degree angle. So this ratio root 3 upon 2 is sine 60 degrees. And that is option A. Second part of the second question. 1 minus tan square 45 degrees divided by 1 plus tan square 45 degrees. So draw a right angle triangle in which the acute angles are marked as 45 degrees. So the equal sides will be 1 unit and the hypotenuse will be 2 units. So tan 45 from the figure is opposite upon adjacent, and that will be 1 upon 1. On substituting in the given expression, we will get 1 minus 1 square divided by 1 plus 1 square, that is 0 upon 2, and 0 upon any number is 0. So the correct option is D. The third part of the second question contains 0 degrees and 90 degree ratios. Since these two angles are deleted from the portion, we are going to skip this question and move to the fourth part. 2 tan 30 degrees divided by 1 minus tan square 30 degrees. In first part of the same question that we are solving, we have written down value of tan 30 degrees, that is equal to 1 upon root 3. So we will find the value of this expression by directly substituting this value. So we get 2 into 1 over root 3 divided by 1 minus 1 over root 3 square. This is equal to 2 upon root 3 divided by 1 minus 1 over 3, that is 2 upon root 3. Add these two numbers in the denominator, we get 3 minus 1 in the numerator, that is 2 upon 3. So we will write the next step as 2 upon root 3 into 3 upon 2. Take the reciprocal of denominator. 2 and 2 gets cancelled, and we will write 3 as root 3 into root 3. So we are left with root 3. So which of these options will have value root 3? Since we have 60 degree angle and 30 degree angle, let's draw a right angle triangle with 30 degrees and 60 degrees and mark the sides. We have to look at the figure and find the angle to which this ratio belongs. Now there are two angles. This ratio will belong to both the angles. Let's see how. Root 3 upon 1 will be opposite upon adjacent if I take 60 degree angle. So this will be equal to tan 60 degrees. And root 3 is adjacent side to 30 degrees and 1 is the opposite side. So if I take the ratio root 3 upon 1 with respect to 30 degrees, then that ratio will be adjacent upon opposite, which is cot 30. So root 3 upon 1 can be written as cot 30 degrees as well. But cot 30 is not given in the options. So our answer is option C. Next question, which is question number 3. If tan A plus B is equal to root 3 and tan A minus B equal to 1 over root 3, where the sum of these two angles A and B is greater than 0 but less than or equal to 90 degrees and angle A is greater than B, then find the values of these angles. Now this is a different type of question where trigonometric ratios are given in the form of two equations. So what we have to do is, since there are two variables, we have to form two linear equations in two variables. So let's take the first equation, that is tan a plus b equal to root 3. Now we have to write root 3 in terms of tan of an angle, because on the left side we have a ratio that corresponds to tan of an angle. So root 3 also must be written as tan of an angle. So let's draw a triangle which is right angled. Mark 30 degrees and 60 degrees. Hypotenuse will be 2, opposite to 30 will be 1 unit, and opposite to 60 is always root 3. Now tan of an angle is opposite upon adjacent. So in this triangle, root 3 upon 1 is opposite upon adjacent for 60 degree angle. So root 3 upon 1 is tan 60 degrees. So we have tan a plus b equal to tan 60 degrees. Now remember, we have to write down the same ratio. This is also opposite upon adjacent and this is also opposite upon adjacent. You cannot write tan a plus b equal to sine of some angle or cos of some angle or cot of some angle. Now this equation over here means that two ratios are equal. So if two ratios are equal, then the angles for which these ratios are written are also equal. So this implies that a plus b is equal to 60 degrees. Now this does not mean that tan and tan are cancelled. If you strike off tan, your step will be marked wrong. These two steps simply mean that here we have two ratios equal, and hence we can equate the angles for which these two ratios are written. Let's mark this step as 1. Now take the second equation, tan a minus b equal to 1 over root 3. So again this is opposite upon adjacent. So we have to write 1 over root 3 in terms of tan of an angle. So 1 is opposite side and root 3 is adjacent side for 30 degree angle in this figure. So 1 upon root 3 is tan 30 degrees. Again remember, we have to write only the ratio for tan of an angle on both sides. Only then we can equate their angles. So tan a minus b equal to tan 30 degrees implies a minus b is equal to 30 degrees. Mark this equation as 2. Now solve equation 1 and 2 using elimination method. So we can add these two equations and eliminate b. So we get 2a equal to 90 degrees. So a is equal to 45 degrees. To find b, substitute value of a in equation 1. A plus b is equal to 60 degrees. So b is equal to 60 minus a, that is 60 minus 45, which is equal to 15 degrees. So we have got the values for a and b. Question number 4. State whether the following are true or false. Justify your answer. Now the first part and the last part of this question are going to be skipped because they are related to the ratios of 0 degree angle and 90 degree angle, which is deleted from the portion this year. However, it is good to know these ratios, because if you choose science stream in higher class, that is in 11th standard, you will be expected to know these ratios. So I'm going to share these ratios with you, the basic ones. Sine 0 degrees is equal to 0. The value of sine 0 is 0. Sine 90 degrees is 1. Cos 0 is 1 and cos 90 degrees is 0. I've shared this extra information just for your knowledge. It is completely up to you whether you want to learn it or not. So we will start answering from the second part. The value of sine theta increases as theta increases. We know the value for sine theta for three angles, 30 degrees, 45 degrees and 60 degrees. So let's write sine theta for these values and then check whether they are increasing or decreasing. So sine 30, we know it is equal to half, which is 0.5. Sine 45 is 1 upon root 2, which is equal to 0.707. And sine 60 degrees is equal to root 3 upon 2. On calculating, this number is 0.8. So observe that as you increase theta, the value of sine theta also increases. So this statement is true. Look at the third statement. The value of cos theta increases as theta increases. So we are going to do the same thing here for these three angles. We will find cos theta. So cos 30 degrees, cos 45 degrees and cos 60 degrees. The value for these ratios should be on your fingertips by now. Cos 30 degrees is root 3 upon 2. Cos 45 degrees is 1 upon root 2 and cos 60 degrees is 1 upon 2. So we have already calculated these numbers, which are 0.8, 0.7 and 0.5. So notice that as you increase the angle, cos theta goes on decreasing. So this statement will be false. And the correct statement will be as theta increases, cos theta decreases. Fourth statement, sin theta equal to cos theta for all values of theta. Now notice in these examples, sin 30 degrees is half and cos 30 degrees is root 3 upon 2. So if I take theta as 30 degrees, sin theta will not be equal to cos theta. But if we take theta as 45 degrees, you can see sin 45 is equal to cos 45, as both these ratios are 1 upon root 2. So only for one value of theta, that is 45, these two ratios are equal, but not for all. So this statement is false. With this, we come to the end of this video lesson. Your assignment for today is example 8 from the NCERT textbook, which is a similar question to the one that we have done in today's video lesson. See you in the next class. Until then, goodbye.